Unit 1. Just like all great detective stories, we start with reaction kinetics.
I understand that you're a curious man, Detective Hebden, but this is my case, not yours. Plus, it's obvious what happened here. The CHHH mixed with the COO and caused the room to fill with COO. It was a regular reaction, not murder. You know, molecules colliding in collision theory.
Kinetic molecular theory.
The kinetic molecular or whatever. The point is we got small spheres bouncing off each other, transferring energy. This is quite literally the basics of chemistry. I thought you were good at this stuff. Do I need to go into exothermic and endothermic reactions too? A good reaction occurred, we measured its reaction rate, and it was a bit quick for this type of reaction. Nothing important happened here though.
All reactions have a minimum amount of energy, or ME, for a molecule to be able to react. This amount of energy is directly equivalent to the amount of energy it takes to even activate the reaction. This activation energy is a little bump on the graph that stops the reaction from proceeding if they don't have enough energy to pass the point. These reaction mechanism steps determine the speed of the reaction.
Okay, talk less. Sheesh. Maybe the activation energy was just a bit lower or something. I don't know.
Thank you, sire. Didn't see that. When it comes to shortening the activation energy, only a few things can make it a bit lower. The concentration, the pressure, the surface area, and that's it. Which all should have been under control in this environment. Plus, the nature of these reactants don't normally react without a certain amount of energy helping it.
Well, Detective, it's a bit warm in here. Temperature can affect reactions, can't it? That's the reason.
Only an idiot would suggest that. Reactions can either be endo or exothermic based on whether or not it holds or gives off energy. The room is warm because the reaction was clearly exothermic and gave off energy. Exothermic reactions go down after the activation energy. And endothermic reactions go up. Yeah, a pepperoni pizza. Hey, what's the address? 0833. This means that the temperature couldn't be a factor. The only factor remaining is catalysts and inhibitors, like in League.
Does he ever shut up?
This had to have been a catalyst, because a catalyst is a separate chemical that doesn't change the reaction, and it does lower the activation energy. This is because it creates a separate reaction mechanism with a lower overall activation energy. The only other thing that affects the activation energy is inhibitors, which do the opposite of catalysts and cause a greater activation energy.
Okay, if I give you this case, will you shut up already?
I'm done.
Dan, we're leaving now.
Okay, bye, Detective. Thank you.
Bye, Dan. I'll miss you. We did it. Stubbornness.
Unit 2. The boring equilibrium one. That is vital to know.
I don't get it. There has to be something that connects these things. That connects this. No, I already checked that. There were no fingerprints. There was no evidence, like pretty much at all. Nothing was found. Absolutely nothing. As long as I have some peace and quiet, I can figure this.
Hebden? Are you there? Are you there?
The chief of police?
Are you there?
Why didn't you say?
On the beach. Equilibrium reactions are widely used in the manufacturing of chemicals. By changing the pressure, concentration, or temperature, a given reaction can be shifted so as to produce more of a wanted product or less of the... They keep saying something about Le Chatelier's principle. Hebden.
Wait a minute. Equilibrium is the missing link. This is what I've needed this whole time. You remember what equilibrium is, right? Well, of course you do, but these people aren't the brightest. Hey there, kids at home. For those of you who don't know what equilibrium is, I'm about to run you through it. First up, equilibrium is a reversible reaction. The reverse rate of the reaction and the forward rate of the reaction is actually exactly the same. At a dynamic equilibrium, microscopic changes do occur, but macroscopic changes don't. And now, if you don't know what macroscopic means, because I didn't, macroscopic means changes that the eye can see. A system that is not at equilibrium will tend to move towards equilibrium. Now, the title may be misleading. Even though it's equilibrium, that doesn't mean everything is equal. It's just the forward and reverse rates. The concentration is actually usually not equal. As long as the rate of consumption of the reactants equals the rate of production of the reactants and vice versa for the product. To predict what type of reaction will occur, you look at the enthalpy and entropy. Minimum enthalpy and maximum entropy is favored. If both favor reactants, then the reaction will not occur as it is already in its ideal state. If one favors reactants and one favors products, they will oppose each other and form equilibrium. Finally, if both favor products, then, as I'm sure you can guess, the reaction will go to 100%. The main law of equilibrium is Le Chatelier's principle. When a system experiences disturbance, it will respond to restore a new equilibrium state. To calculate the concentrations of products and reactants, there is an equilibrium equation which shows the products over reactants equaling an equilibrium constant. The equilibrium constant can only be affected by temperature. Having a high equilibrium constant means having a lot of products at equilibrium, and having a low obviously means having a low amount of products at equilibrium. Oh yeah, no one wants to listen to that much chemistry. Sorry about that. But anyway, we need to tell the chief dippity bottom as soon as possible. ASAP for short. ASAP Rocky if you're trying to be casual, chill, like the kids nowadays. Now, I'm gonna need you to go and start the car. I am going to finish up the novel I was reading. I'll take a shower too. Anyway, start the car. I'll be right there. See ya in about half an hour. Oh yeah, don't waste any time. We're kind of in a hurry.
Unit 3, Solubility Equilibria. Just add water.
So it's the cutthroat chemist again.
Who?
It's the name I gave the guy.
That's a good name right there.
Who are you?
I'm Dan. I brought coffee.
Yeah, alright then. Well, here's the autopsy. He has been dead for several days. I've noticed that he has a metal ring on his finger, clearly married. What is strange is that crystals should have formed, but no crystals did. This man seemed to be just dropped in the ocean.
Maybe we should leave the police work to the actual police officer.
I'm handing it to a person that can actually solve this case. Thanks.
Chuckles.
Don't tempt me, Dan. We'll just buy a Keurig.
Those things don't make coffee to the same quality. You need to know the chemistry.
What chemistry? It's coffee.
There's lots of solubility involved. You need to understand the difference between ionic and molecular bonds. One has ions, the other has molecular compounds. Sugar is added to coffee, salt isn't. But they are both soluble though, just in different ways. I think that's pretty cool. Hey guys, I brought coffee. You guys want some?
You are the worst type of person.
Want to know something else cool about chemistry?
Listen here, bud. We agree on how cool the name Cutthroat Chemist is.
Very.
Thanks again, but I'm the one who talks too much about chemistry. Get it?
I'll be over there.
Good. Also, molecular compounds are made up of nonmetals, and ionic compounds are made up of nonmetals and metals.
Detective, last time I checked, coffee isn't important to the crime scenes.
That we know so far. You gotta always be prepared. What's this about no crystals?
The crystals should have formed on the man's ring if he was left in the ocean water for 48 hours. On the atomic scale, the ionic lattice of the insoluble salt remain intact. The ionic lattice does not break up to allow salt ions to be surrounded by water molecules and so form a solution. I did find that there is lead crystals in the body, all in his trachea, which is weird. Lead alone is poisonous. He somehow had a small piece of lead in his throat and drank the liquid version of it. Rip him.
But how did that stuff get in his body? I mean, is it tasteless?
No, something strong should mask it. Something sweet, sour, or maybe bitter.
Did you know coffee is bitter? Most people use coffee to clear their noses or get the taste out of their mouth. Absolutely great at masking things. It's just two substances with different amounts of concentration reacting.
Like titration, a solution of unknown concentration is combined with a solution of known concentration to find out the concentration of the unknown solution.
I mean, not really. I think that was just you shoehorning titration into the script.
Whoever did this would need to know a lot about chemistry.
Or a lot about coffee.
You're arresting me just for knowing a lot about coffee?
Unit 4, acids, bases and salts. The one that's easy until it isn't.
Today we have an exclusive interview with the one and only Detective Hebden, who's just wrapped up his latest case and caught the terrible Mad Chemist.
Cutthroat chemist.
Oh, I didn't know there was an official name.
Well, there is, and I came up with it myself.
Okay, you use chemistry to solve your cases, correct?
Yes, and one way to define acids and bases is by the Arrhenius theory of acids and bases.
Does this have anything to do with the case?
Asterisk ignores and keep talking. Asterisk. You see, this theory states that an acid is a substance that releases an H plus or hydrogen in water, and a base is a substance that releases OH minus in water, which is also known as hydroxide. Is that what it's called? I got it. That's the kind of chemistry I know. Yes.
Does this relate to the case?
An acid and a base creates a salt and a water. Am I pointing at the right things? The Bronsted-Lowry theory states that an acid will give a proton, whereas a base will accept one. As you can see here, I only showed the proton going with the H2O, but it can go the other way, where there could be an OH here, which will take a proton from water, and that's how that works. An H plus ion can also be described in another way, as a proton.
Right, because a hydrogen atom is just a proton surrounded by an electron. So when it loses an electron and becomes an ion, it's really just a proton.
Right, except I'm the chemist here, so when that proton in water is bound with that water and becomes a hydronium ion, as you can see here, the hydrogen is combining with the water and becoming hydronium ion. A hydronium ion, if you want to sound smart, like the kids these days.
Do you understand what people do at interviews?
The difference between the Bronsted-Lowry theory and the Arrhenius theory is that in the Arrhenius theory, water is neither an acid or a base, but in the Bronsted-Lowry theory, it can be an acid or a base.
Okay.
This is because water is amphiproctic. Now, you might be asking, what's amphiproctic and stuff like that mean? Don't worry, I've got y'all in the audience covered. Another slide. Clearly, I worked myself too hard, I know. Monoproctic acids. So let me just clarify before we start this actually. These are amphiproctic. This is what it means. It's just basically just donating different amounts of protons. Can you see that? Yeah, okay. Monoprotic acids can only supply one proton. Diprotic acids can supply up to 2 protons. Triprotic acids can supply up to 3 protons. Polyproctic acids are acids that can supply more than 1 proton. So basically, the diprotic and triprotic are polyprotic.
Did you make these yourself?
Okay, speaking of amphiprotic things, they are made when a substance, 1, possesses a negative charge and still has an easily removable hydrogen ion or proton. Then the substance will be amphiprotic. See, when I like to think about amphiprotic, my old uncle once told me, Uncle Ben, rest in peace, he always said, when it comes to birthday presents, do you give or receive them? Well, it depends on whose birthday it is. That's why he was a great man. Bronsted-Lowry says that in every reaction there's an acid and a base. Every acid has a conjugate base that lacks an extra proton. And vice versa, of course. Did you know? Vice versa is actually a Latin expression that means the same the other way. I learned this from Google.
Did you write conjugate wrong?
How could you accuse me of such a thing? Conjugate is look, I spelt it right here, here, and here.
No one finds this interesting, so let's move on. To a very special guest. He's a big fan of yours, Dr. Chow.
An acid did this. But it doesn't seem like there are any burns, so it must have been a weak one. A strong acid or base is 100% ionized in a solution. Weak acids aren't. This can make them even more dangerous because in their non-ionized form, they can pass through membranes and easily get in the bloodstream. It can ionize and bond with substances in the body.
Our top story tonight. Detective Hebden arrested the wrong person. This is Newsnet with Logan and Alex.
Alex and Logan. Alphabet.
Cool. Earlier this week, police arrested Dan on a tip from Detective Hebden, who before this had a spotless record of solving crimes. Earlier today on this network's
During an interview I was hosting, another victim of the cutthroat chemist was revealed on live television. On top of this, another 12 people have died from mass pH changes of the blood. For those who don't know that much about the relative strength of acids and bases, here's a summary on the topic. In a Bronsted-Lowry acid-base equilibrium, the side of the equilibrium which has a weaker acid will be favored. A general expression for calculating the equilibrium value can be derived based on the Ka values of the acid involved in them.
The reaction. In the reaction. Yeah, okay, please. I don't think you even understood half of the stuff you just said. Do you even get how the Keck is the ratio of concentrations of products to concentration of reactions?
Keck.
K-E-Q, or whatever. You didn't even get to hydrolysis there.
I was getting to it.
Okay, well, maybe you've been a bit faster there, hon. Okay, so, hydrolysis.
Hydrolysis of a salt is the reaction between the water and cation and or anion contained in the salt as to produce an acidic or basic solution. Was that fast enough?
Okay, people are dead, Alex. Be a bit more mature. Now, unlike Alex here, acids and bases are both helpful and useful and serve a purpose. You know, our own body is a constantly changing environment that's sensitive to pH changes. That's why we have buffers in our own system. If changes are either acidosis or alkalosis to the pH in our blood, it can be lethal.
Sadly, the newest killings were from a pH level below 7.2, and the equilibrium in our blood shifting to the left, causing the oxygen and hemoglobin to not properly cooperate.
Well, unlike Logan, chemistry doesn't cry during commercial breaks, one of which we now need to go to. See you guys next time.
Okay, listen here, you little...
Yeah, I think we've seen enough of that.
Maybe we should leave the police work to the actual police officer.
If you find a compliment officer, please let me know.
He thought it was equilibrium, and it was acids and junk.
What?
Acid-base equilibrium.
He's right. Most acidic solutions are at equilibrium. We have a whole section about the equilibrium constant for the ionization of water. Neutral constant having an equal level of hydronium and hydroxide. Acid ones favor hydronium and the basic ones favor hydroxide. Not to be mean, but I can hold up my own sign. This is the equilibrium expression for it.
Hey, I know I'm sad not talking much, but talking about chemistry and boring people to death is still my thing, so leave it to my inner monologuing.
Sorry.
Seeing as how they already covered a good chunk of this chapter, let's just start off by explaining indicators. It makes just as much sense as everything else. Indicators are weak organic acids and bases with different colors for their conjugate acid and base form. The indicator goes into its acid conjugate form when it's in a highly acidic solution, and it goes into its conjugate base form when it's in a highly basic solution. I don't know what I could have missed. Maybe titrations, but that comes up a lot throughout all the chapters. In order to have a titration, you must have a solution with a decently known concentration, which is referred to as a standard solution. You use the standard solution to titrate with other solutions to determine their concentration. You'll need a primary solution, which is a solution that is in its pure and stable form, that doesn't absorb water or carbon dioxide. Titration gives off either a acidic solution with a salt of a strong acid and a weak base, or a basic solution with the salt of a weak acid and a strong base, or a neutral solution with the salt of a strong acid and a strong base. A buffer is a solution containing a pretty decent amount of weak acid and its conjugate weak base. When a nonmetal oxide reacts with water, the water and the oxide bond, creating an acidic solution. So basically, I got it! Let's finish this on my walk home. When a metal oxide is added to water, there is usually a dissociation that leaves oxygen with water, making the metal ion a spectator, while the basic solution is being formed with the H2O and O. Assistant, I think I figured it out.
Unit 5, Electrochemistry. We're almost bloody done here, thank God.
The Greek symbol toph, which looks like a T, is the mathematical symbol for 2 pi. Since there are 2 of them, 2 times 2 equals 4, so 4 pi. If you have the half reactions of copper and iodine, and you have sulfate and potassium, you can make an electrochemical cell. An oxidation reaction is a half reaction that loses an electron. A reduction reaction is a half reaction that gains an electron. For every reduction reaction, there must be an oxidation reaction and vice versa. Either of these half reactions can go either way, but if they are in a redox reaction, a reaction involving the loss or gain of electrons, one has a greater tendency to reduce or oxidize than the other. Iodine has a greater tendency to reduce because these half reactions are part of a redox reaction. I should change this equilibrium symbol. Asterisk changes symbol asterisk. We know the reaction will be spontaneous and go to 100% completion because the reactant to be reduced is above the reactant to be oxidized on the table. If H+ is present, it must be treated like any other reactant. But if it's not present, it's not that important. Before half cells are connected, there's a small tendency for the metals to oxidize and produce positive ions. The electrons given off are deposited on the metal. Once the half cells are connected, an excess of electrons accumulates on the electrode with a greater tendency to oxidize, and the electrons will flow through the wire to the cathode, which gains electrons and is reducted. The solutions don't mix, but some ions pass through the salt bridge. Positive ions will form around the anode, leading to an excess of positive charge. The cathode is reduced and there's an excess of negative charge. This causes the anions to move towards the anode and the cations to move towards the cathode. Voltage, or electrical potential, is the work done per electron transferred. We can only measure the difference between two half cells, not the voltage of the individual cell. This cell here is at standard reduction potential. If the cell doesn't meet these requirements, it can change its tendencies to reduce, and therefore the cell potential. If a half reaction is reversed, then the sign of its standard reduction potential value is reversed. Here, the standard reduction potential is positive. That's another way to tell that the reaction is spontaneous. If lithium was in this reaction, the cell would have to choose which reaction to use based on which reaction has the highest reduction potential and which has the lowest. So it would use lithium and iodine. The copper would be a spectator ion, however, lithium isn't here. An oxidation number is the charge an atom would possess if it were made of ions. There are some assumptions that we can make regarding oxidation numbers. If these make carbon monoxide, which has a charge of 0, and we know oxygen has a charge of -2, then it can be determined that carbon has an oxidation number of 2+. We know that fluoride has a charge of -1, meaning carbon in tetrafluoride has the charge of +4. We only need the oxygen now. H2 and O2 are some of the major elements of corrosion, which is the oxidation of metals. Some ways to prevent corrosion is to provide a protective layer to prevent the O2 and H2O from getting at the metal. Or you can supply another metal that is more likely to corrode or oxidize so that it acts as an anode and the original metal stays on its reduced form. Or you could change the metal surroundings so they don't include H2O or O2. In an electrolytic cell, the reduction half reaction is below the oxidation half reaction, and therefore the reduction potential of the cell is negative. This means the cell is not spontaneous and there is no need to keep the reactants separated. To get the cell to work, the voltage must equal the reduction potential of the cell. If the cell is in an aqueous solution, the reduction or oxidation of H2O must be considered. You must also find the preferred half reaction, which will be the one requiring the least voltage input. These will still be the reactants that are most likely to reduce or oxidize. If the solution is acidic, the reduction half reaction will use H+ instead of H2O. Electroplating and electrofining are types of electrolysis. Electroplating has an object placed in a solution of the metal it will be plated as, and then made to act as the cathode so the metal will build up on the object. Electrorefining uses an impure anode that removes the atom from the anode that is most likely to oxidize. As that atom oxidizes off, it collects at the bottom of the cell and can be collected. Wait. That's upside down. Oh, there it is. What is this? What does it mean? It's the chief of police. It was you. You're the killer.
Well, I mean, obviously. There's like 4 characters, and I left you a note saying I was the killer. You're kind of bad at your job.
I blocked it.
I got you again. Gotcha. He's dead.
Blocked it. Ooh.
Enough of this! Out!
Hey guys.
I'm not the best thrower.